I want to look at a really great concept. It's called reciprocal functions. You know what a reciprocal is because if I give you something like 2, you know the reciprocal of that is going to be 1/2. Or if I give you something like 1/4, the reciprocal of that is going to be 4. Well, you can do the exact same thing with an equation. Look what I gave you here. Okay, I'm going to let you get f of x equals to x. That's all I'm going to do. So in other words, y equals to x. So that's all I'm going to do. So if you look at a table of values, which I've got in front of you here, if you're looking at f of x here, in this case, y equals to x, -5 is just -5. So if you go here onto our graph and go 1, 2, 3, 4, 5, there's -5. Well, that's going to give you 1, 2, 3, 4, 5, and they're going to join up right about there. It gives you that nice little point. -4 is -4, -3 is -3, -2 is this, and so on and so forth. Now, you're probably wondering why I'm going into specifics. You'll see what I mean in a second, but I'm going to just jump down to 0, skip all of these fractions because they're just going to equal each other, and that's going to be 1 and that's going to be 2. So basically, you're going to get a function that looks like a line that goes through the 0, 0 mark, and away we go. Everybody's happy. And then you could just draw a nice little beautiful line here that goes all the way through this, and ta-da. Now, here's the thing that I want you to look at. Remember, if we're reciprocating things, in other words, we're flipping things, it's all you got to do here is then just flip. So instead of this being -5 now, this is -1/5. This is, instead of being -4, reciprocal, which is 1 over the original function, is -1/4. Reciprocal again, -1/3. Reciprocal again, -1/2. Reciprocal again, -1. Now, here's why I left this section out, the circled section, because normally it would be -1/2, right? But what's the reciprocal? The reciprocal would be -2. Ah, isn't that interesting? Isn't that interesting? So that'd be -2 here. What's the reciprocal of -1/3? That's going to be -3. Reciprocal of -1/4, it's going to be -4. Reciprocal of 1/5, -5. Now, here's the interesting thing. Can you do the reciprocal 1 over a 0? No, you can't. It's undefined. That's not allowed. So in other words, being that it's not allowed, think about it. It is a non-permissible value. Awesome. So in other words, you can't have divided by 0. That's going to open up a whole can of worms for us later on. We're going to take a look at. Take a look at this. This is 1/5. So now it's 5. And we'll just do it from here. That's 4. That's 3. The reciprocal is 2. The reciprocal is 1. And then again, with the 2 here, it'll be 1/2. And we go to 3, it'll be 1/4 or 1/3. With 4, it'll be 1/4. With 5, it'll be 1/5, and so on and so forth. I want to plot this. I want you to see what this is going to look like. Look at -5, and we know it's -1/5. So here we all are out -5 here, but -1/5 is only right about just barely below the line here. Look at this. At -4, I'm -1/4. Look at this. I'm right about here or so. The next one is -3. Here's -1/3. So I'm about there. Okay, -1/2, which is about here. -1 and -1. Look at how all of these are the same. So that's this point right here. Now watch what happens. This is the cool part. At -1/2, which is x is a -1/2, which is about here, okay, this thing jumps now to -2. Oh, isn't that interesting? Right to about here. -1/3 jumps to a -3, so we're about here. -1/4, -1/5. So in other words, we're getting really, 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 really close to this. But if you even think about it, we go all the way down here to, let's say, -1 over 1,000, right? You still reciprocate that. That's going to give you a value way down here of about 1,000, but it's still not touching the axis. So what kind of graph do you get? Well, what happens here is you get a graph that hugs this line, then goes over like this, and then goes straight down like that. Boom, on this side. That's what a reciprocal function is going to be. Let's do the other side. Check this out. 0, 0, undefined. Well, wait a second. That means I can't have anything on the 0. Well, no kidding. Well, this graph here, if you look again, gets close to 0, but never touches, because 0 is a non-permissible value. Check this out. Let's go to this side now. 1/5 is 5. 1/5 is about here, but now we're jumping 1, 2, 3, 4, 5. We're about here. Okay, cool. 1/4, which is a little bit more out, okay, is 4 right there. 1/2 is about, or 1/3 is about here. 1/2 is about here. Look at this. 1 and 1 is another point that is the same here as it is here. Look at that. Isn't that interesting? Then you start going out to these numbers and look what happens. You get the exact same graph here going down here like this, cutting through our 1, 1, and going out here, and again getting closer to this axis and getting closer to this axis, but never really touching it. Never really touching it. Why can't it touch this? Because it's a non-permissible value. That's really, really cool. So look what happens as an inverse function. Your inverse is 1 over x. And if you can remember your non-permissible values, right, x cannot equal to 0. And this point right here, that line right there, is actually where x equals to 0. And notice that the graph comes close to it but never touches it. This is actually called an asymptote. That's what it's called. It's called an asymptote. So what you have to do is you find the non-permissible values. In this case, x cannot equal to 0. Put a little dividing line down here right through where that x equals to. You get an asymptote, and guess what? That's where the graph hugs close to but never ever touches. That's really, really important. This one is called a vertical asymptote because why? It goes up and down. Look at this one over here. Notice the same thing happens here. Right there. This gets closer to this 0 mark but never touches it. So guess what? That's called a horizontal asymptote. Okay? Asymptote. Okay? That gets close to it but never touches. A couple other things that you have to look at. Look what happens here. We know that these two dots are exactly the same. These are called invariant points. Invariant points. In other words, they're the same whether you do a reciprocal function or whether you do the normal graph. These 2 points will always be the same here. What's another thing to look at? One of the things is look at what this thing is doing at the end here and at the end here. It looks like it's increasing, and it's increasing that way, getting close to the 0 but never touching it. So when you're talking about these kind of things, either here, here, or out here, talking about it going this way, or that way, we call that, and I don't know where to put it. Oh, let's put it here. End behavior. What is happening at the end points of your graph? What's happening at the endpoints of your graph? Well, in this particular case, it's increasing, getting close to this asymptote, but never touching it. This one is going out further out here. That's increasing, but never touching the asymptote. This one, of course, is going in this direction, so it's decreasing, never touching the asymptote. And of course, this is going down, which means it's decreasing as well, never touching the asymptote. Those are all the key words and things that you have to know about a reciprocal function. So let's take a look at a couple more examples in our next podcast.